Finding the equation of a line through two given points is actually really similar to finding the equation of a line when you know one point and you know the gradient. Because of course, if you have two known points, let's call them x1, y1 and x2, y2, then you can easily find the gradient of the line that connects those 2 points. You just chuck them straight into your gradient formula. This is nothing new, you already know this. Now, once you've got the gradient and you've got 2 points, you're spoilt for choice because point gradient formula, this one, only requires you to know 1 point in the gradient, and you've got 2 points now and the gradient. So step 1, find the gradient using your 2 points. Step 2, you can use either point and the gradient, which you've already found, to find the equation of the line using point gradient form, which is this one. Now, what have I written down here in red, and why have I made it a different colour? Well, some people like to do these 2 steps in one go, which is absolutely fine. How would you do it? Well, if you wanted to do both steps at once, they call this point-point form. Now, if you have a look at this equation here, you're going to notice it actually looks a lot like this one. It's got the y minus y1, the same, and in brackets it's got the x minus x1. The only difference is, where this one has an m for gradient, we're just using that part that we know gradient is, all of this, and we've just substituted it straight in. Some people like this because they think, oh, just remember my point-point form, and if I've got 2 points, I've got my y2s and y1s and x2s and x1s, and I just throw them all in there, and my equation of my line comes out. Go ahead. Now, it's not totally essential. Why not? Well, because it's exactly the same as just finding the gradient first, and then substituting that gradient in here. Now, don't forget, you've already got a few things to remember. You have to know what general form looks like. We know that one looks like this. It's got the x's, y's, and the other numbers all on the left-hand side, and then it's got the 0 on the other side. You've also already got gradient intercept form. Gradient intercept form. And that looks like y equals mx plus b. And that's a really handy one because it gives you that gradient and y-intercept. Makes it very easy to graph. So these are the 2 main ones that we want to express our straight lines in. We've also got this point gradient form now, which is really handy when we know the gradient and we know 1 point, or as we've seen, if we actually just have 2 points, we can use it. So I've got point gradient form. And a lot of people think, look, that's enough forms, I'm getting confused now. I don't want to memorise a whole heap of different things. And that's totally fine. If you just know these 3, then you have everything really, because this extra one with the 2 points, point-point form, it's really just point gradient form in disguise, isn't it? And I've just taken the gradient part and chucked the formula for gradient in right there. So you can remember it as a separate one if you want to, but it's the one that's kind of like an extra because it's really just this one with an extra complexity added to it. So let's do an example. When we have 2 points, find the equation of a line, in general form this time, of a line that passes through -2, 3 and 4, 5. All right, first thing we want to do, find the gradient of this thing. So if you like to write down this equation every time so that you feel confident, it helps you remember it. On the next line, make your substitutions. Now, which ones do you call the 1s and the 2s? It doesn't matter. But whichever one you start with it both times. So I'm going to go 5 minus 3, because I know that's nice and straightforward. Gives me a positive answer. And then I'm going to go 4 minus 2. Now, that gives me 4 plus 2, doesn't it, which is 6. So I can see I've got 2 over 6. If you want, you can do your working like this, or if you could have spotted it straight away, that's 1/3. Next step, now I'd probably just keep on working down, but because I'm reaching the bottom of my board, I'm going to move across here. Next step, write point gradient form. So you can see what it looks like. I'll do that every time. And now, toss in your ingredients. We've got M. We need to choose a point. We can choose this one or this one. It really makes no difference. I'm going to choose this one because it's got nice positive numbers in it, but it really wouldn't matter which one. So y minus 5 equals 1/3 x minus 4. All right, next we've got to put it into general form. So I'm going to expand my brackets first. I've got third x minus 4/3. Now I want to get rid of my fractions, so I'm going to multiply everything by 3. I could have actually done that at this point here, whatever. 3y minus 15 equals x minus 4. And now I need to tidy up and get everything on the same side. I'm going to bring these things to this side because this has got my positive x's. So I'm going to leave nothing over there. That means I need to subtract 3y from both sides. So I'll have my x here. I'll subtract 3y from both sides. It's vanished from there and I get minus 3y here. And I'm going to add 15 to both sides to disappear this minus 15. So if I've got minus 4 plus 15, that's going to give me plus 11. Now I just need to rewrite it so that I have all the terms on the left and the 0 on the right, so everything's just swapped places.